Jordan's not here today, is that right? Okay, we'll just continue then. All right. Well, hope you had a good week because it's been that long since I've seen you guys, right? And I guess you guys had that one program last Thursday. So, you guys ready for math? Yeah. Henry's like no expression. He's like, yes.
I think so.
Okay, good, wonderful. All right, so let's talk about divisibility first. And what we have there on page 31 is a chart of divisibility rules, okay? So with divisibility rules, there's certain things that are always true and help us to look at a number that we're unfamiliar with and determine right away, is it divisible by this number? So let's talk about that first. So I'll draw this up here just to look like what's on the page. And let's go with 2. And let's write the rule. Okay, so how do we know if something is divisible by 2? How do we know? Ends in an even number. Okay, so the last digit is even. Let's write that in there. So given that, and as is 558 divisible by 2? Yes, it is. So let's write this in our book just the same way as I'm writing it up here. Let's go to the next one. Who knows the rule for whether something is divisible by 3? Anybody here know the rule? Go ahead, Maggie. That's right. The sum of the digits is divisible by 3. So I'll write this here. So for this one, what is the sum of our digits here, Henry?
Well, 5 plus 5 is 10 plus 8 is 18. 18 is divisible by 3. 18 divided by 2 is 6. So yes, I think so.
So that's a yes right there. You guys see that?
Yeah.
Good job. So I'm glad you guys know the rule. That's awesome. What about the rule for 4? Does anybody know the rule for 4? Anyone? Okay. The rule for 4 is that the last 2 digits represent a number that is divisible by 4. So I'll write that in here. So divisible by 4. So our last 2 digits are 58. Henry, is that divisible by 4? Without a remainder. A lot of people are like, well, anything's divisible, just punch it in the calculator, right? But without a remainder. Henry?
No, I don't think so. Well, since the nearest one is 4 times 13 is 4 times 13 is, I think, 52. 4 times 14 is 56.
Right. Yeah. So it's 14 with a remainder too.
Yeah. It would be 14 with a remainder too, so no.
That's a no. Okay, so that means 4 does not go into 558. Now some of you guys are like, well, why do we go to all that effort for just a number like 558? We're using this as a sample, but if the number was bigger and it was like 1,375,558, then you're like, okay, let's do it faster this way. Okay. What is the rule for 5? Henry, your hand is halfway up.
Well, I'm pretty sure that's not divisible by 5.
You're sure? Okay.
That's pretty sure.
Okay.
That's not divisible, but I don't exactly know the rule, maybe.
Okay.
Maybe I guess in 5, 10, 15, 20, 25, 30, 40, I guess that's maybe when I get this number isn't it? So like, I guess maybe since 5 only goes in that pattern, as far as I know.
Right.
In which case it goes up from 75, so 5 or it has 0 on it.
Ends in either, Ineza, you had it? 5 or 0. Ends in either 5 or 0. So the last digit is either 5 or 0. So it's either 0 or 5, okay, for the last digit. So this is obviously a no, okay. What about the rule for 6? Who knows the rule for 6? Anyone? Take a stab? It's the number of people that, You're close. You almost said it, Megan, but you're close. Kiana? It's both 2 and 3. So if a number is divisible by both 2 and 3, okay? Divisible. So this one is obviously a yes, because we already proved yes and yes right here. Okay, good. So let's talk about the next one, which is the rule for 9. Who knows the rule for 9? It may sound familiar, but the rule for divisibility for 9 is that you add up the digits, and if it's divisible by 9, then the big number is divisible by 9. So it's the same thing. The sum of the digits divisible by 9, okay? So we did this. 18 is divisible by 9. That's a yes. Okay. So the last one, I think, is the easiest one. What's the rule for 10? Henry?
Well, I know we're down to know the one.
Okay. You're just raising your hand because.
Anything that's also between 1 or 5, if it's 10, like, I guess there's only 0.
Yeah, it only ends in 0. That's it. Okay, so it ends in 0. So this is obviously a no. Okay, so 558 is not divisible by 10. Yes, Henry. Question?
Yes. So we're taking similar to the rule for 5. Okay.
Similar, but it's not. Yeah, no 5s at the end.
It's only 0.
Yeah, that's it. Okay. Okay, let's continue to the next page. We got a lot of stuff to cover today. So a couple things that I want to talk about. So let's just go through these little problems first, and let's talk about these first. Let's just go straight down the line. Ineza, what's the 10th digit of 1345? It is 4. Okay. Arrange these from least to greatest, Megan.
Right now.
Yeah, do it now.
Sorry, I didn't. Negative 17.
Okay.
Negative 3.
Okay.
0 to 3.5.
That's right. Okay. Usually when they give you a set of numbers, they don't put them in order. So it's good to do that. All right, let's go with the number 3, Kiana. Why don't you read it to us first? And the remainder is? It is 5. Okay, correct. This is super easy, Henry. Which of the following is not even?
Well, I think it's the 861.
Right.
And stutters all have a 752, except that the means is 2.
Right.
23 is even 38 0.
Exactly. Okay. Good. That's good. It was an easy question, so perfect. Excellent. Okay, excellent. Excellent. So let's go to number 5. Ineza, you want to read that one for us?
12 minus 6 divided by 3 plus 7.
Okay, good. So that's what we have there. Why don't you solve that for us? Where do you want to put them? Who agrees with Ineza on putting parentheses there? Ineza, of course. But why would you put parentheses between this and this? Why would you do that?
Because you're dividing.
Okay, I would actually not put the parentheses there. Megan?
Because you always do division and not division first and not right.
Yeah. So what is the rule called?
What is it?
PEMDAS, right? So I'm going to write it up here. Right. So when there's no parentheses there, what's the first thing we should do here? Henry?
Well, I guess the first thing to do out of all those would be division, just that higher.
Right.
Or that, before you come up, you can do that before you do it in subtraction.
Right. So given that, what is 6 divided by 2? Pretty easy, Henry.
6 divided by 2 is 3.
Okay, so let's do this. We'll rewrite this. 12 minus 3 plus 7. Does it matter whether we do the addition first or the subtraction? Henry?
I don't think so.
It doesn't matter. Megan, what should we do?
You start from left.
Just go left or right on this, right? So what's our answer here? Yeah. Since you told us what to do. It's 16. Yeah. So yeah, when it comes down to all this, PEMDAS is kind of our rule of thumb that we're going to follow. Okay, great. Wonderful. Let's go to number 6 here. Since Megan solved that one, I'm going to go straight to Kiana on this one, number 6. You want to read that for us? Right. So what should we do first on this one? Okay, you can do the division first. And what do you get? She gave us the final answer. Okay, that's fine. Good job. Okay, wonderful. I thought you were going to walk us through. But let's let Kiana walk us through. She got the correct answer. Tell us what she did here. She's like, ding, final answer. Okay. She's like, I don't play games. I'm all about the final answer. Okay, so tell us what you did here. Okay. Okay, so, no, okay. What did you get for 9 times 7? What? 63. So this is 63 plus 6. And that's where she got 69 for that one. Good. That was the answer. That's correct. But what you guys can see, she did the multiplication and division first before adding. The adding came last, right? Even when the parentheses aren't there, we're still able to follow the rest of the rules of PEMDAS. Okay, good job. So let's go from there. And Henry, number 7, tell us which of the following numbers are prime.
Well, if you can use the table to finish divisibility, I remember that.
Yeah. Yes.
We haven't done yet. Which I haven't currently done yet.
That's okay. It's all right. Just get that chip from Best Buy, plug it in the back of your head, and your memory will be way faster. You'll have like photographic memory. You'll be like, I think it's like 20 megapixels. So it'll be awesome. Okay. And it has videos too. All right.
When you look at the table that you get for 8 divided by 2, well, it's still after yeah. So that's 8 divided by 2 is 4. So it's 13, then you can go with all these and all these ratios are then get into the other thing. So I don't think it's divisible. It's not divisible. It's divisible. The last is straight numbers. Well, this is well,
so you've knocked out 8. That's composite. 13, you said was prime. Okay.
Well, 51, I guess.
51.
The last digit is not even, so it can't be divided by 2. Another digit is divisible by 2. 5 is 1, 6 divided by 2. So yes, it's divisible by 2. That's 17.
That's right. It is divisible
By 3.
by 3. So that's composite. Okay.
59, so if you can look at the goal again, no like two number becomes a digit. 14 is not unfiltered as you want to. Last one is group makes it big number divisible and 4 no. And 5 or 0 no. So then in 2 into by 2 and 3 isn't really cancel out. If the number digits is by 9, you know, and it can be 0. So I think it's fine.
Yeah, it is prime. Okay, good.
And then
last one.
The last digit even. No. Is the sum of the digits, if the sum of the digits is divisible by 3. So, well, that's 11, so no.
Mm-hmm.
If the last digit is divisible by 4, 6 times divisible by 4. If it ends in 5 or 0, no. If it's divisible by 2 and 3, well, we already canceled that out for sure. If the sum of the digits is divisible by 5, that's fine as well.
Good analysis there. However, it is not prime. There's one thing that doesn't have a solid rule to it, and it's 7. This is actually divisible by 7. If you divided this by 7, what are you going to get?
17.
Equals 17. Okay. So this is not prime. It's composite there. That was a little bit tricky there. But the bottom line here is that I like what Henry did there. And you guys might have been saying, what the heck? I need to get that chip and put it in the back of my head so I can memorize faster. But he was looking at the page, which is a good thing. It's a good device. To make it even faster for all of you, just look back at the page for just 1 second. If you just saw something and saw that it was not even, you've already knocked out 4, 6, and 10. Because even numbers are only divisible by even, okay? You can't divide an even number by an odd without a remainder. So if something was not even, 2, 4, 6, and 9 are out just like that. If you know it's not divisible by 3, it's also knocking out 6. But then you're just really down to 3, or we already talked about 3, but 5 and 9, just like that. And then you can, 5 is easy to spot, right? Because it's either 0 or 5 at the end. So that's the fastest way to do that. Some of you guys are like, dude, I don't want to memorize. It's actually very easy and helpful, okay? But that's how I would do it. I just look at it first, is it even? And that just knocks out a lot of stuff, right? So, okay, let's continue. Good job on that. Let's go to number 8. And Nezla, you want to read that? Okay. What would you do first here? Okay. So let's do that. We know, which one do you want to name first? PS, that's the whole thing right there. That's 20. Okay, what else? PR, 16. I'll label it here. Okay. And then any others? Okay, QS. Okay, good. All right, so we have those 20, 11, and 16. How do we find QR? That's really the question. Any suggestions here? My suggestion is use every piece, okay? Some people are like, well, let's just like take one and then the other and like we're done, okay? What should we do? Henry?
Well, I guess I'm just trying to think, well, when PR and QS, well, they both include that part of the line, I guess. So I guess you try it for, well, you have to do it.
Yeah, we don't have PQ. Any other suggestions from anyone? Yeah, Henry?
Like, what? Well, no.
Okay.
That's it.
Megan, your hand was halfway up. No? Or was that just like doing the hair?
No,
Okay, something in the eye. Okay. Kiana? I wish we could. But the problem with subtracting P, oh, you said PS. Okay, yes, you can do PS. I thought you said PR.
no.
PS, yes. I like that. That's what I would do too. So you're gonna subtract QS from PS, right? What do you get? You get 9. Okay, I like that. So I did that in blue. 9. I like that. Okay. So we have 9 for PQ. What else can we do here? Counter, you want to finish this? Henry?
Well, we already, well, I think you were done that. PQ is 9, so, and then PR is PQ and QR, so if you take out the other, you can find out, if you take out 1, you can find out it, right? 16 minus 9, which I think is equal to 7. So I think so that equals 7.
Yeah, because this is the same area right here. So this is 9, this is 7. So QR is 7. That's correct. Okay, good job. Excellent. Teamwork. Everyone did it together. So good job. Let's go to the next one. Number 9, Megan, you want to read that for us?
You spent $57 on a shirt and a blouse. If the blouse cost $29, how much did the shirt cost?
What do we do?
We subtract 2.
Okay, what do we get?
38.
It's 38, actually. It's 38 because you're going to take 1 away from there. Anyway. 28 would have been too much, but yeah. Yeah, 38 is the correct amount. Okay, that's correct. All right, let's go to Henry on this one. Let's have you read number 10 for us.
Franklin and his little brother Kevin saved $143.75 together to buy a computer game. If Kevin saved $68.37, how much did Franklin save? I think this is another simple, I guess, subtraction problem.
Right.
And that you're trying to find out X for the remainder by taking out the other one.
Okay.
So I think we're subtracting $68.30 from $143.75.
Yeah. So let's do that.
Which I think equals $75.45.
That's right. This is 45. This is 75. Correct. That's the correct answer there. 75.45. I think all of us got this pretty good. I think we understood this. Before we move forward with regular problems that come from the SSAT and the ISE, I want to establish some definitions of math terms because I think it's easy to speak generally. Sometimes we just talk about numbers, but with these math writers, when they write these questions for these tests, they use certain terminology to tell the test taker, people like you and me, what type of numbers you're supposed to be using, okay? So let's start with the first one. What does that say? It says a digit. What is a digit? Any number? I'm sorry? This is where we're getting specific. Digits is like, for some people it's like, yo, did you get that girl's digits? No, that's not what they're saying. No, but that's like phone numbers, but that's totally not what they're talking about here. So, but what is digits? There's actually a math definition of it, okay? Your expression speaks a million words there, Megan. That's hilarious. Digits, I'm going to be specific, represent single digits from 0 to 9. Okay? So digit is a single digit. Digit is a single number, 0 to 9. Okay? Because some people throw it around very generically, but when they're talking about digits in math, they're speaking about a single number between 0 and 9. Okay? Let's go to the next one, Megan.
Integers are,
What's your definition of integer?
a negative or positive number.
Okay. Is that it? You're on the right track. But it's not all the way there. Henry, can you make it more specific?
Well, from the category of real numbers, I guess so if it's positive and negative numbers, or it's the positive and negative numbers that I guess. So anything that includes from like negative infinity to positive infinity.
What about negative 3.5? Is that an integer? Megan?
No.
No, why not? You're an integerist. What is an integer then?
A negative or positive number that is not a decimal.
Yes, yes. We're on the right trail. Basically,
Or a fraction.
I'll save us all the energy here. It means integers are whole numbers.
Oh, wow.
Positive, negative, or 0. 0 is neither positive nor negative. So whole numbers, so integers. Okay, whole numbers, positive, negative, or 0. Okay, that's what that is. All right. Let's go to the next part. Tiana, read that. Yeah, I think we've established that. Positive is greater than 0, negative less than 0. Let's go to the one after that. Go ahead and read that. Okay, how do we know if something is consecutive? That's what we want to talk about. You have the idea, Megan?
I guess. Is a list of numbers set off by commas?
Commas, like,
In a row.
yeah, there's a comma after me, so get that comma after you. All right, so
Oh, it's like a list
is
of
this
numbers.
consecutive? Is this, you guys say yes or no to me on this one. 1, 7, 9, 13, 14, 16, 18. Is that consecutive?
Yes.
Yeah?
Uh,
On which planet?
I have no idea.
This is not consecutive. Why? Henry, tell us why this is not consecutive.
Well, this is called any pattern, I don't think.
Right.
I think
Oh.
it's not even like odd or even consecutive number that it goes like 1, 3, 5, 7,
Right.
1, 2, 3 in that order. So it doesn't really have any pattern or follows a pattern that follow a pattern that could consistently create itself as a differ from that pattern.
So consecutive numbers follow a consistent pattern, usually increasing or decreasing. Okay? So usually increasing or decreasing. So I'll write that in there. Okay, good. Good job there. All right, so would this be, I'm just going to put up 2 or 3 samples. I just want a yes or no on that. Is this consecutive? Henry?
I think so, since it goes 1, 3, that's 1, plus 2.
Right.
3, 5 is plus 2, and 5, 7 is plus 2, and 7, 9 is plus 2.
Yeah, this is a consistent pattern of increasing numbers. They just turn out to be all odd numbers. Okay. Would this be a set of consecutive numbers here? What do you guys think? 5, 1, -5, -9. What do you guys think? Tiana?
Yes.
Yes? What's going on here?
Because there's only decreasing by 4.
Yeah, it's decreasing by 4. So I know that we often think of numbers, oh yeah, just like alternating even numbers or alternating odd numbers or something like that. But even this, where it's taking a pattern of subtracting 4, these are consecutive, yeah.
It's decreasing.
This is decreasing, yeah.
So -5 is 4 less than 1.
Mm-hmm. Oh wait, it should be, actually, I wrote that one wrong. That one's wrong. It should be -3 and then -7. That's better actually. -3, -7. That's actually better. The other one would not have been it, but this one is. So you're right. I actually wrote that wrong. But yeah, this is decreasing by -4. Okay. So that's kind of what we're looking for on this one. So I just threw these out there. The final thing I was going to say about consecutive is this. If a math problem simply says consecutive, but doesn't designate consecutive even, consecutive odd, then it's just numbers that follow by 1, right? 1, 2, 3, 4, 5, 13, 14, 15. Those are just straight consecutive. Yeah, Henry? Your 2, 4, 6, your 1, 3, 5. Yeah. So if it doesn't designate at all, it's just simply the numbers that go 1, 2, 3. Okay. All right, let's continue with the next one. Henry, read that.
So it says, what is a multiple?
Okay. You tell us.
I'm not exactly sure I'd say exact definition. So I guess maybe perhaps I should have a stuff, I guess. 14 would be a multiple, so I guess so numbers that can from one number be multiplied by that number.
Kind of. Your example works, but your definition wasn't exactly on. Let's talk about it. Let's use what Henry just said there. So 14 is equal to 7 times 2. I like that. Okay. In this example here, the multiple is 14. What are 7 and 2? They're numbers, yes. What are they, Henry? No one wants to say anything. They're like, I don't know. Okay, Henry?
Factors?
They're factors, right. So this is, the good way to look at it is factor times factor equals multiple. So for some of us, we often confuse whether 14 is the factor or whether 7 and 2 are factors. But think of this as factors are parts and the multiple is the result. So I think of it this way. Okay. And if it helps, I'll write a sentence here. Does this help when I write these sentences? 14 is a result of 2 times 7. 2 and 7 are factors of 14. So the words are very interchangeable. Do you guys see how that works? And it's easy to think of factors as parts, multiples are results. Okay? Write all this down. I know that we have a lot of stuff there. So what's the definition of factor? What's the definition of multiple? Well, write down a factor is a part, a multiple is a result. Write down all this stuff for what's the difference between the two. Because the difference is that multiples are the end result of multiplying. Factors are what you use to get that. You guys see where it says what's the difference? You can just write it right there. There's a bunch of lines for you to write on.
So for multiple, you put factor times factor.
Multiple, yeah, is equal to factor times factor. Result is equal to part times part. 14 is a result of 2 times 7. 2 and 7 are factors of 14. Does that make sense? If 14 is a multiple, you could use either word. You see this? 14 is a multiple of 2 and 7, right? That makes sense, right? Okay, so we already talked about remainders, right? Remainders represent things that are left over when you divide, and they can be represented as fractions, decimals, or with a remainder. Okay, we're all familiar with that, right? And then we talked about PEMDAS, which is at the bottom of the page, parentheses, exponents, multiplication, division, addition, subtraction. Any questions on this, or does anybody want me to do any other examples of factors and multiples, or you guys are ready to roll? Remainders are things left over when you divide. For example, if you had 22 divided by 3, right? You know that 7 times 3 is 21, and you have 1 left over. Here's your remainder of 1. This can also be written as 7 1/3 or 7.33. Those are all remainders. When something doesn't divide evenly and it has a remainder, it can be written as remainder 1. It can be written as 7 1/3 as a mixed fraction, or with a decimal 7.33. You can see that, right? Okay. Any other questions? Other things that you guys want me to clarify? Let's move forward here. Let's turn the page. And on this page, you have basic operations. Let's have Ineza read this problem for us. Okay. So when you see something like that, what would be your first reaction of how you would solve that? PEMDAS, yeah. And obviously a lot of these answer choices have parentheses, have multiplication, some of them have subtraction or addition. So we should go through each of these. Why don't we just spend a minute and crunch numbers and find out which of the following equals 16, okay? Go ahead and do it. Okay, did we have an answer here for this one, Megan? B? Tell us how you did it.
I didn't write it down.
You did in your head, okay. Well, let's walk through it. Just tell us what you did.
Okay. So I multiplied 8 times 3.
Yeah.
Then I subtracted it from 5 plus 3, which is 8. So it's 16 somewhere.
Wait, that's 5 plus 3. I wrote that wrong. Not 8. So that's 8. That gives you 16. None of the other ones give us 16, so this is the only one. By following PEMDAS, this is the only one that gives us 16 here. Okay? Good. Let's continue here. Let's go ahead and I want you guys to, let's go with number 2 here. Let's have Kiana read this one.
135.
Yeah.
The whole number x is between 1 and 5. If x belongs to 8, what is the value of x?
Okay. How do we go about this one? Do you have an idea, Kiana? Not totally? Okay. Henry has his hand up. You want to tell us what you did first?
One of these is between 1 and 5, and it's also between 3 and 8, so that's if you can figure out 1 and 2 on that number line. It's also a whole number, so you can remove any decimals, so yeah, if there's any decimals.
Let's slow it down a little bit. Okay, let's slow it down just a little bit. I like what you said already, and I want to take it piece by piece. Before we continue, Kiana, are you going to add something different here? I wanted to show you guys one thing. Since it's between 1 and 5, does X include 1 and does X include 5? Henry?
Well, since it's between 1 and 5, so I guess it's not greater than or equal to, so I think it doesn't include it.
You're right, it doesn't. So it should look like this. When you have greater than or less than signs here, and you just say between, it means it's not necessarily equal to it. So this set right here up top only includes the numbers 2, 3, and 4. 2, 3, and 4. What about the set down here? Megan, do you want to tell us something else? Did you have something that you want to add?
No.
You're going to say the answer? Well, let's walk through this. What would you do here, Henry?
So you said, so 3 is less, so X is greater than 3 and less than 5.
Yeah, well, greater than 3, less than 8 for this set. So what's included in this set?
So that's 4, 5, 6, 7, 8.
Is
Or 7, sorry.
8 is not included. Yeah.
It's not greater than or equal to. So 2, 3, 4. So what are these those sets? Well, that's 4.
Right.
That's a real number where the set and because it's a full number, it can't also be a number at a decimal.
Right. No decimals. That should have been knocked out immediately since they're using whole numbers. Right. So our answer is 4 on this one. That's the correct answer. Good. Okay. Let's go to Ineza. Why don't you read number 3 for us?
What is the greatest integer less than 32?
Okay. You have it already, Megan?
Yeah.
What is it?
3.
3? Are you sure?
No.
Okay, let's double check that. Ineza, are you still working on it? She's still on it. Okay, Henry, hold on for a second or two. Let's see what answers we get here. Since I kind of gave a clue that it isn't 3.
Oh,
Wait, okay. Oh, wait. Okay. Okay, I'll give you another chance since you answered it.
So I didn't do the division. So the answer is 4.5 for 33 divided by 7.
It's
You can round to 4.
right.
So it would be wait.
4 remain.
It's
It's 4 remainder. It's 4 remain. 4 remainder, not 4.5. It's 4 remainder 5. There's a difference between saying 4 remainder 5 and 4.5. There's 2 different things. Okay. In other words, this is 4 and 5/7. Okay. All right. But what's our answer here? It should be C. It should be 4. That's the only integer, or the closest integer to 4 and 5/7. Okay, that's correct. Does everyone see how we got 4 and 5/7 here? Yeah, you're just dividing 33 by 7. It goes in there 4 times, you get 28. 33 minus 28 is 5. That's how you get that. Okay. Good. Let's continue here. Let's have Henry read number 4 for us.
60 minus 4, so it says 60 minus 4 parentheses 5 times 2 plus 12. According to Sunrise, you should do what's in the parentheses first. Which equals 60 minus 4 parentheses 10 plus 12.
Yeah, you got this 10 now, and you still have this 4 here. What do you do with it?
Well, 4 times 10 is that's correct.
You want to multiply because the other ones are subtraction.
And that's greater than those, right? So 60 minus 40 equals 20 plus 12 is 32. So I think it's 32. And then I guess I could double check that.
But that's the right answer. It is 32. So that's correct. All the steps that Henry took were correct. He did the math inside the parentheses. He did the multiplication next. Then he did subtraction and addition. That's correct. Okay. Good job there. Okay. Let's move forward to positive and negative exercises here. Let's go with Ineza. We want to read number 5 for us.
5 plus negative 8.
Okay. What's going on there with 5 plus negative 8? Do you want to walk us through it?
Well,
Not really? Okay.
so did you have to,
I just want to walk through it first rather than just the answer. I know you guys are like, I got the answer. I got it. Okay. All right. Henry, do you want to walk us through this, or do you want to just give us the answer? What do you want to do?
Well, I think so 5 plus parentheses minus 8. So
Yeah.
minus and plus, so I guess you could, so 5 plus minus 8, I guess you could also say.
Yeah, you can restate this as 5 minus 8
Which equals minus 3, I'm pretty sure.
equals negative 3. Okay. And for Ineza, just think of a number line here. If this is your 0, you're starting off at 5, right? And since you're subtracting 8 units here, you're going 1, 2, 3, 4, 5, 6, 7, 8. That's your negative 3. You see that? So that's what takes us there. Okay. But when it comes to doing this kind of stuff here, sometimes it helps for some people to just switch them around, but recognize that negative 8 is actually going to be the one that has the final say with positive 5. And if you just went 8 minus 5 equals 3, but then you said, I know it's negative 8, so I need to switch it back, and you can call it negative 3. Some people do it that way. Is that how you learned it? That's tough, though, because the problem with that is sometimes people forget it. This, so that, you don't get this part?
no, I do.
You do get
That's
it.
how I learned it.
That's how you learned it. Okay, that's cool. The switching thing, I'm not a big fan of it, but some people do. It's confusing, and some people forget.
There's more words you have.
Yeah, so I'm just trying to touch on everything. I think that I gave a visual and kind of gave everything right there, but all right. That switching thing only works if it's a very, very simple problem. But okay, let's go to the next page. Let's do a couple of these problems here. Let's go with number 6. Let's have Megan read this one, number 6.
5 minus negative 5 minus.
And what happens here?
Well, since you have to start with it. Okay, you start with parentheses, but since there's a negative number right in front of the parentheses, negative 5, that negative 5 turns to a positive number.
Right, so this becomes 5 plus 5 minus 5,
Which is
just 5. Okay, that's right. That's correct on that. Okay, good. These are pretty straightforward. I think you guys are getting these. Kiana, you want to do number 7 for us?
5 negative 6.
Yeah. So what's going on here?
Negative
Right? So what is going on here now? The final answer is 40. Yeah, this is basically 5 times 8, which is 40. Correct. All right. I think she was dealing with the negative 4 and the negative 2 first, which is 8. So correct. Good job. Good job. Henry, you want to do number 8 for us?
Yes, please. So negative 3 divided by 6. So I think that, well, no, I think that's negative 0.5.
That's right.
Since 3 divided by 6 is equal to, so there were, I think there were 6 1/2, which is equal to 6.
Right. A lot of people make the mistake of thinking 6 divided by negative 3, and they choose negative 2 as the answer. That's not right. You know, this is numerator, this is denominator. Sometimes it helps to reset it and write it like this, -3 over 6, so you get the -1/2. Everyone's good with that? Okay. You guys are all doing really well here. Okay. Let's turn this page and let's talk about factors, multiples, primes, and consecutive numbers, because we spent a little bit of time defining factors and multiples. Before we start, what is a prime number? Can someone tell me what that is? Yes, Henry? Well, the consecutive part doesn't play a role with prime, but you're right with it only has a factor that 1 and itself. Yeah, but don't worry about that part. Yeah, no, I'm only asking about prime, but don't mix the two, because they don't prime and consecutive are not related to each other. They're kind of separate of each other. But prime, his definition of prime is simply a number that is divisible by itself and 1. So when you look at a number like 2 or 3 or 5 or 7, the only numbers that go into them are 2 and itself, 3 and itself, 5 and itself. But if you look at 4, right, there are different numbers that go in there. You got 1 and you've got 2 and 4. 3 different factors here. This is just 1 and itself, 3 and itself. I mean, 3 and 1, 5 and 1, 7 and 1. That's a better word. Yeah, so that's kind of what we want to look at right there. So 1 and itself is basically what we want. So let's look at number 9 here. Ineza, you want to read that for us? Okay. Greatest common prime factor. Megan? 14 is a prime number?
Oh.
Whoa. Okay. Too excited to answer. Kiana? B is 7. Tell us how you got that.
7.
Yeah, 7. Well, 7 times 4, and then 7 times 6. I would actually break these down, and right below there you can see factor trees. Have you guys done factor trees before? Factor trees look like this, right? You break them down because you're trying to get down to the prime numbers where you can't divide anymore. This would be 2 and 2. This would be 2 and 3. The only prime numbers that go into 28 are 2 and 7. The only prime numbers that go into 42 are 2, 3, and 7. So the greatest common prime factor, I should put a P here, greatest common prime factor is 7, okay? So the greatest common prime is what we're looking for. Okay, good. That's what that is. Just to reiterate and talk about prime numbers for a second, there are a lot of tricks you'll see on the test. I'll ask you one of them here. Is 1 a prime number? We're indecisive here. I'm trying to give the poker face. Okay. Henry?
Well, if it is divisible by nothing other than 1 itself.
The answer is no. The answer is no. 1 is not a prime number, and that's a trick question there. A lot of people think it's prime, and if there was a list of numbers like prime numbers that go into 42, people would accidentally choose 1, 2, 3, and 7, but 1 is not prime. Okay, so I want you to write that down on there. If you don't know that, write it in big, bold letters. 1 is not prime. Okay, are negative numbers prime? We're not totally sure?
Yeah.
The answer is no. Yeah, and Ezra's like, just pointing, she's like, no. Well, that's not the reason behind it, but I'll show you something here. Let's look at -2, okay? -2, the numbers that go into it are 1 times -2, 2 times -1, right? So there's 4 different factors here, right? For a prime number, the definition is the only factors are itself and 1. Itself and 1. So that means -2 would not be prime. And actually, when prime numbers were created, they weren't even thinking of the negative numbers. They were only doing this with regard to positive numbers. So don't even, there are no,
Negative numbers are not.
right. So negative numbers are not prime. Okay, good. Good job, everyone. Let's look at the problems on the right. Let's go ahead with number 10 here. Let's have Kiana read this one for us.
What are these common multiples of 18 and 30?
These common multiple of 18 and 30. Does anybody have the answer here? Don't overwork yourself. There's only 5 answer choices. Okay, Ineza? 90. Tell us how you did it. That's correct.
18 times 5 is 90 and 30 times 3.
That's right. So just looking at the answer choices, we know 30 doesn't go into 18. 18 doesn't go into 30. A and B are gone just like that, right? Then you look at 60. We know that 30 goes in there, but 18 doesn't. Then you looked at 90, and Ineza said, well, that's 5 times 18. That's 3 times 30. That's got to be it. Okay, so that is our answer. I know some of us might have been doing a lot of work right there, but sometimes looking at the answer choices is a faster route, especially if all the answer choices are numbers and you can work your way backwards. So just go through a process of elimination. Okay, let's go to number 11. Megan, read that one for us.
How many prime numbers less than 45 are divisible by 7?
Okay. Read the fine print on this one. I'm going to tell you now it's a trick question. Read the fine print on this question. Henry, you have the answer?
If it's less than 45, well, 7 itself is divisible by itself.
What answer do you have before you tell us how you do it?
Oh, wait,
Maybe one that I thought, so maybe 0, I guess, if that's something.
You're not reading the fine print. Megan?
is it 0?
You're not reading the fine print either. Okay, the fine print is how many prime numbers are divisible by 7? There's only one. It's 7. Because if you look at the multiples of 7, all right, 7, 14, 21, 28, 35, 42. This is the only prime number, right? These are not prime, right? So this is a trick question because it's going to make you do all this work here. You're like, let's do all the multiples of 7 all the way to 45, right? And you go 7, 14, 21, 28, 35, 40. Okay, I made it to 45. Okay, let's see which ones are prime. prime, not. Okay, it's 7. Okay, I did a lot of work for no reason. Okay, but if you think about it, if 7's prime, then 7 can only go into itself as just 7. Everything else is not prime. They're all composite. Okay, good. Let's continue here. Let's have Henry read number 12 for us.
If one is the sum of consecutive full numbers is 84, what is the average of the sum numbers?
You got it?
Well, sum one is very beautiful. Right? So starting from 7 less than 84, I guess that. So I think that's 77, 78, 79, 80, 81, 82, 83, 4, 40. So I think that's 78, 79, 80, 81, 82, 83, 84.
So he listed out the numbers. You went from 77 or 78?
78.
Okay, 78. Okay, 79, 80, 81. Keep going.
And then next I guess you have to find average. So I guess the mean would be 80. So I guess it's 78 plus 79.
You gonna add them up? I'm gonna stop you now. Okay. Does anybody know the faster way? Don't add them up because you'll spend a lot of time. They're not friendly numbers, and you're sitting there. You're like, oh, let me add this stuff up. What he did is correct. These are 7 numbers, with the highest one being 84. They are consecutive, and there's a rule when you have consecutive numbers that the mean, i.e. the average, is the same as the median. So the rule is when you have consecutive numbers, the mean equals the median. Okay, question there, Megan?
No.
Henry, question?
No.
Okay, I want you guys to write that down. When you have consecutive numbers, the mean equals the median. So if that's the case, what is our mean here, since that's what they're asking about, right? What is our average? Megan? 81? You got the same thing, right, Henry?
Yes, it's 3 on both sides.
Right.
And that's the middle number, I guess.
This is your mean. Yeah, it's the mean and the median. If they're not consecutive, you can't use that simple rule. You do have to add them up and divide it by 7. Okay, but since they're consecutive, that helps us. Let's do this. Let's take a little break, 5 minutes. If you need to run to the restroom or anything like that. Okay, let's do that. All right, good. There's a practice quiz, but I'm going to save that for later. I want to get through all the lesson first, and then if we do that, we'll come back to the practice quiz. So let's turn a couple pages to where it says the Collegible method for word problems. Okay. Let's have Ineza read. It should be right there, one page over. Okay, on the left. Yeah. Okay, read that for us.
Translate the words into equations by parts, not by sentences. Step 1, translate words into numbers and math. Step 2, determine what the question is asking for. Step 3, use given information to form an equation and solve the inverted question.
Great. Translation is crucial to problems on the SSAT. More than half of your problems are going to be word problems. They don't just hand you the equation and say, go ahead and solve it. And it's like, ta-da, I got it, right? What they do is they just hand it to you in a sentence, and then you've got to create your own equation. So that's kind of what we want to do here. And what I want to emphasize here is that you've got to translate the words into math. And you need to do it part by part. Sometimes when you read an entire problem, it takes 3 sentences and you're kind of like, okay, what do I do? Right? And you're kind of like, it's too much information for me. Go part by part. Just start with the first sentence, translate from there. Okay? Then move to the second sentence, translate from there. And then when you're done with all the translating, then you calculate. Okay? And then you do it again in Chinese. I'm kidding. I'm kidding. I'm just kidding. And then you do it again. I'm kidding. I just wanted to get a laugh out of you guys. So. All right, let's go to number 1. Let's have Megan do that one for us. Yeah, if you can. I'm kidding. Did you take it?
A Coke house contains 24 soccer balls, 2/3 of which are white. If exactly 8 of the white soccer balls are inflated, how many of the white soccer balls are not inflated?
That's a lot of information, right? So let's go part by part. So you end up having to do that. But let's translate just the first sentence. Do that first. Go ahead.
A clubhouse contains 24 soccer balls, 2/3 of which are white.
Let's translate that. What do we do? Do you want to tell us, Henry? You have an idea?
Plus, we just want to get 2/3 of 24 soccer balls. So 24 divided by 3 equals 8. 8 times 2 is 16. So we do that 16 of the soccer balls are white.
Okay, let's take a break right there. That's good. What he said right there could have been just written as 24 times 2/3. It's the same thing. Some people might have written it that way. Some people want to take it step by step, which is what he did, which is fine. He divided it and multiplied it, and he got 16 white. What do we do with the 16 white soccer balls after that? Henry?
Well, since it's exactly 8 of the white soccer balls are inflated, which how many of the white soccer balls are not inflated?
Okay.
We're trying to find out how many of them are not inflated. So you could say that. So if there are 16 of them and 8 are inflated, that's 16 minus 8 equals that.
So he's going to subtract the inflated. Okay.
16 minus 8 equals 8, I'm pretty sure.
Okay.
So that 8 of the soccer balls are not inflated.
Okay. So yeah, so 8 are not inflated. That's exactly how we do it. He goes piece by piece, and he basically goes to the second sentence and takes away the 8 from the 16. And when you are able to do that, you build on the information that's given to you, and you end up with the right answer, which is 8. Okay? Any questions on this? We're all good? Okay. Let's go to the next page. All right. So on the next page, let's have Kiana read number 2.
What is the lesson from the being studied?
Who wants to set it up? You want to set it up first, Megan?
Oh,
Okay, and then do it in Chinese. I'm kidding.
so you just add 3 and 7.
Okay.
And this is 10 and subtract it by 2.
And then you have 10. Your final answer is 8. Okay. the bottom line here is that the language in this sentence is tricky. How many of you guys looked at this and thought 2 minus the quantity of 3 plus 7? Some people mistakenly think it's 2 minus 3 plus 7. Okay, that's not correct. Even though it says 2 less, a lot of people think that means 2 minus. It doesn't. It means you're taking the 2 away from the 10. That's what you're doing right there. So that's a type of language trick that test makers use that you should get used to. Whenever you see that, psychologically, you got to say to yourself, I'm putting that 2 and I'm taking it and I'm subtracting it from the other part. So I'm going to put it over there. I'm not going to put it in the front. I'm going to put it in the back. Okay. Let's go to number 3. Let's have Henry read number 3 for us.
Well, 3 says, Jody earns $50 per week. Carl earns 3 times as much as Jody per week. How much will Carl earn per week? So J equals $60, C equals 3J, I guess. So that equals 60 times 3 equals $180 per week for C. C times 180 times 4, or 4C equals 52, 4, 6, 520.
It's a little bit different. More than 5. What is it?
So you multiply 60 times 3 and then times out by 4.
Yeah, so it's 180 times 4. That's where he was. He's right. What is it?
Oh, you want to do the answer?
Yes.
Oh, I'm sorry.
Yeah, but what is the answer?
7.
It's 720. Yeah, he had it, but he said 520 originally, but it's 720. Yes. Henry?
Sorry, I was doing my headphones.
That's all good. It's all good. We always do that. I saw you, you just got to go to Best Buy, get that chip so you don't have to, do it in your head. It's easier. So, all right. So anyways, this is right. $60. Carol has 3 times that amount, so it's 3J. And then that means she has $180. That's all we did. We multiplied 60 times 3. Multiplied by 4 weeks, 720. So that's correct. Okay. Let's go to number 4 here. Let's have Inessa read this one.
Lauren spends $50 per month on entertainment, which is twice as much as half the spend and $30 less than Josh spends per month on entertainment. How much does Lauren, Patrick, and Josh together spend on entertainment?
Okay. Let's start from the beginning. We got to do some translating from the beginning because that's like 3 sentences worth of information or 3 lines worth of information. So what do we define first?
Lauren spends $50 per month.
So how do we define that? Don't read anymore. Define that as an equation. No, define it as an equation. Have you used variables before?
Yeah.
Okay, so what do you call Lawrence then? Let's call him something else. What do we want to call Lawrence? L. Okay, Lawrence is L. And what do you say about L? Equals 50. Okay. Okay, I like that. L equals 50. Now what do we do? $25. He's half of Lawrence. Okay. Okay, 25. Next one, Inessa? Right. He's more than Lawrence by $30. That's correct. Now what do we do with it? You add them up. Go for it. Because we need the total for all 3 guys, right? $155. Is that our answer? What's our answer then? So it's not 155. So this is because there are, right, 2 months, 310. So multiply by 2, 310 is our answer, since we have 2 months. Some people get excited. They're like, yes, I found everything. I found what Lawrence got. I found Patrick. I found, what's this third guy? Josh, right? I found all of them, right? Even though I don't know them, right? And I added them up. I got 155. And they circle 155 because it's there as an answer choice. And they see it, they're like, it must be that, right? But they forget 2 months. That's another TestMaker trick that they have there. They try to get you excited about going through all the steps, translating everything, and getting a number, but then forgetting to multiply by 2, okay? So be careful with that. Read the fine print, okay? Let's go to the next one. This is all good right here. I think all of you guys did a great job. Well, before we move on, I want to mention this. On the remember notes here on this page, these are great translation notes here. When you see words that say sum, plus, more than, that means addition, right? Minus, less than, difference, between, decrease by, they all mean subtraction. Those are good. And then right below there, you can see times, product, multiplied by, and of. They all mean multiplication. And where you see divided by, over, quotient, and per, and out of. Do you guys see that in the column on the right? On the page on the left, you see that? That's what I'm reading to you guys right there. Remember notes. There are 3 remember notes there. And then lastly, words such as is, equals, and equivalent. Those are all equal signs. When we're doing translation, these words will pop up all the time, okay? So we got to be familiar with them. We can't be kind of hazy with it and kind of go, I think I know what quotient is. I'm not totally sure, okay? We have to know what these words are because we need to translate, okay? So let's do some translation exercises on the next page here. And we'll just do them in order. Let's have Megan read number 1 for us. Yeah, on the exercises.
Why isn't 5 more than X?
How would you translate that into an equation? Y is 5 more than X.
Y equals 5 plus X.
Right. Y equals 5 plus X. Does anyone have a different one? Okay. Let's go to the next one, Kiana. Number 2.
I have X.
R equals, okay, I'm writing what you have there. Well, is there any other way to translate half? It is what it is. Half is half. Okay, it's nothing more than half. Half is a number. So we should write a number there. 1/2. What's of? I actually just read this to you. That's right. Okay. So yeah, you could write it this way. Some people write it as S over 2. Some people write it as 0.5 times S. They all mean the same thing. Okay? Those are all the same. Henry, do the next one.
Well, X is twice as great as Y. So X equals 2, or X equals 2Y.
X equals 2Y. That's correct.
Or 2 times Y.
Yeah. X equals 2 times Y. That is correct. Okay. That's great. Okay, let's go with number 4, Ineza. Remember what I said about that language there, right? So if you're stumped right now, the first thing I would look for is the equal sign. Which one is the equal sign here? Yes, the word equivalent. So you have that. And so what does that tell you? What's going to be on the right side of the equal sign? So n is going to be here. Okay, you got that. And what's going to be on the left side of the equal sign? Just by itself? 2m? Read it again. Correct. m minus 2. A lot of us get stumped when we see 2 less than m. And I told you guys a few minutes ago that that's a trick, right? And we don't want to write 2 minus m. It's m minus 2. That's correct. So that's the right answer. M minus 2 equals n. It looks a little bit vague when you read it. And you're kind of like, what exactly is that? But when you start with the equal sign, and then you put that n, then you're kind of like, okay, I got done with half of it. I just need to deal with the right side of it, right? Which is what you ended up doing. Or the left side of it, right? The left side. You finish the right side, and you need to do the left side. Okay, let's keep going here. Let's go with Megan, number 5.
The product of A and B is 3 more than their sum.
Okay, it's a lot of translating here.
Yeah.
Did you say something? Like, I don't know this one. I don't know this one. Say it louder because the microphone can't hear you. Anyways, it's okay. Anyways, let's go with Henry. I'm just kidding around with you there. All right.
So I think so A and B, the product is equal to AB.
Okay.
N is equal to equal. Right?
Let's slow it down for a second, Henry. So the word product, remember that list that I just read to you guys? What does product mean, Ineza? Right, so that's why Henry says right here, for this right here, this just means A times B. And then this is an equal sign. So we're done with the left side, just like that. Henry, you want to keep us going with this?
Well, their sum is well, according to the one we just did, equals division. So sum equals A plus B, that's their sum. So A plus B, I think, is the sum, right?
Their sum right here, okay, A plus B.
A plus B, and then 3 more than is plus 3. A
Right.
plus 3 plus 3.
Yeah, so 3 plus. And then because this is 3 more, it doesn't really matter whether you add it before or add it after, because this is going to be the sum, which is going to be in parentheses anyway. So, question there, Megan?
Yes. And on the left side, you have this A times B. Can we just say AB?
Yeah, I just wrote that there just to emphasize that product means multiplication. You can write AB. That's totally fine. Yeah. Yeah, that's totally fine. Okay, that's good. Good job there. All right, let's go to number 6 here. Let's have Kiana read number 6 for us. A lot of words, right? Let's just start with the first part of this. We don't even have 3 sentences, we just have 1. And the first part says, divide the sum of 6 and 9. So let's just write this. When I look at that, how should I change that? Henry, what would you do with that?
So if we were going to change that, I just divide it by 6 and 9. So 6 and 9, sum equals add. So 6 plus 9 equals 15.
6 plus 9.
So you're going to divide something that equals to 6 and 9 or 15.
Right.
Divide 15.
So this equals 15. Okay. That's 15.
You need to divide it by 15.
And the second part of this says, by the positive difference of 7 and 2. By, let me write this, the positive difference By the positive difference of 7 and 2. What do we do with that? Megan?
Use the top two and
Okay. So you have 7 minus 2, and that equals 5. So now you just have division, right? Henry, what were we going to say?
So equals 15 divided by 5 equals 3.
Right.
So your answer would be 3.
Yeah, the answer is 3 there. That's correct. I'm going to talk about the phrase positive difference for a second. A lot of people saw that and they're like, what? What is positive difference? Sounds like Obama. Make a positive difference or something like that. Anyways, I don't know if it was political or anything, but positive difference, I'll tell you what it is in math. In math, it means you're taking the absolute value of whatever you subtract. So if you looked at 7 and 2, obviously it's positive 5, but if you said 2 minus 7 and that equaled negative 5, you want the positive difference, so you take the absolute value. So I'll write this here. 2 minus 7 equals negative 5. Positive difference is 5. Do you guys see that? So if you had negative 5, you take the absolute value, those bars. You guys have all seen that, right? Absolute value? Okay, good. Henry, did you have something else to add?
Yes, so the whatever number that it started with 0 or positive value.
The distance, yeah, away from 0, and it's designated with a positive number. Correct. That's right. Okay, good. Let's go to the next one. That was Kiana. Henry, do you want to read number 7 for us?
Number 7. Multiply the positive difference of 9 and 7 by the sum of 3 and 4. 19.
Yeah, well, let's break it down with the translation first. Can you do that?
Multiply the positive difference of 9 and 7. So the positive difference of 9 and 7 is, I think it says, so 9 and 7, 9 minus 7, or I said minus 9 absolute value.
Right.
So 9 minus 7 equals 2, and then you're going to multiply that with something that says by the sum of 3 and 4.
Okay.
It would be 3 plus 4.
3 plus 4.
The sum means add.
Right.
Say equals 7.
Right.
2, and then 2 to multiply 2 by 7. So 2 times 7 equals 14.
That's right. That's right. So we're multiplying overall. First part was the positive difference of 9 and 7. The second part was the sum of 3 and 4. Sum of 3 and 4 is 7. Multiply, it's 14. So even though it's just one sentence here, there's a lot of information that we need to translate before we get to the calculator. The calculating is the easiest part, right? But if we don't translate it right, it won't come out right, okay? Let's go to number 8. Ineza, you want to read that?
Find 3 more than the product of 5 and 8. So the product is 5,
Okay.
and multiply 5 and 8.
Okay.
Which is 40. And more than is added.
Right.
So 40 plus 3 is
43.
40.
Correct. That's right. That's correct. So that's good translation there. And she did that. All right. So let's go to number 9, Megan. You want to read that?
Sure. Find twice the positive difference of 9 and 3. So you subtract 9 minus 3,
Okay.
which is 6, times 2.
That's twice the positive difference. And your final answer is
12.
12. That's right. 12 is our final answer there. Correct. All right. Kiana, the last one here.
Number 13 and 16 and 5 is divided by 14 is divided, so 13 divided by 5 equals 8.
Okay. 15 divided by 5. Okay, right there. Okay. Is it 7 plus 6?
Oh, wait, not 5.
Product is multiply.
42.
Right. 7 times 6 equals 42. What do you do with it? What's the overall thing you got to do? Ineza? You got to add.
Yeah.
That's the first thing they tell us. Add You're really, if you look at that sentence, you could almost put parentheses around the first part. The quotient of 15 and 5, put a parentheses around that, and then put a parentheses the product of 7 and 6, and then you got yourself the addition right there. So the answer should be 45. Okay, good. Okay, good job. All right, this is good stuff for you guys. Let's do this on 11, 12, and 13. These are all translational exercises here. First thing I want to do here is go to number 11, and I want Henry to read this and translate what you're solving for and then what information you have here. So start with that.
Well, the last part of the sentence says you're trying to find how many stamps there are as well. So you're first trying to find out whether the last part of the sentence is. So what information are you given? So the sentence, or those sentences state Rob has 22 stamps, and Sarah has 40 more stamps than Rob. If Sarah gives 15 stamps to Rob, how many stamps to Sarah as well? So I guess you can divide that into parts. So the first sentence says, so R equals 22, S equals 40 plus R.
Okay, let's slow it down right there. So we know Robert has 22. So we'll say R equals 22. That's correct. Next part, what did you do there?
So I said S equals 40 plus R, or S equals 40 plus 22 equals 62.
So Sarah has 62 stamps. Okay. Next, what's the next thing you want to do?
Well, the next page says if Sarah gives 15 stamps to Rob, how many stamps will Sarah have left? So 52 minus 15 is what you're trying to find.
Right, that's what you're looking for. After she gives her 15 stamps. So what you're solving for is you're given the information of how many stamps they have, and you're solving for how many stamps Sarah has after she gives 15 to Rob. That's what you want to say there. So, and then how can I use it? Well, we're doing it right now. We're calculating. What's our final answer when Sarah has given it? Ineza? 47. That's correct. 47 stamps remaining. Okay. Good job. All right. Let's go to number 12. Ineza, you want to just read that for us?
Before the market opens on Monday, a stock is priced at $25. If its price decreases $4 on Monday, increases $6 on Tuesday, and then decreases $2 on Wednesday, what is the final price of the stock on Wednesday?
A lot of information. Let's take it day by day. Okay, that's literally what's going on here. Let's start with Monday. What goes on with Monday here? Okay, so we're given this information. What are we given? We're given information about Monday, Tuesday, and Wednesday. Okay. What are we solving for anyways?
The final price.
Right, so you're looking for the final price. Okay, you're looking for a final price there. So walk us through what you would do here, Ineza.
So M equals 25.
Mm-hmm.
And
What happens on Monday?
it increases $4. So it is
Okay, so you're subtracting 4, you get 21. So then what do you do?
it then increases $6 on Tuesday.
So you go from 21 plus 6, you get to 27. So Wednesday, what happens?
But then it increases $2. Back to 25.
Back to 25. Okay. Kind of circular there, but you got to the right answer. And those were the correct steps. You have given information from Monday. You're trying to find the final price on Wednesday. Your answer is 25, and that would be the right answer there. And that's just following the steps that they give you throughout the sentences. Okay, good. Let's go to 13 here. All right. Let's have Megan read that.
Diane teaches 1/3 of the room, 2.5 to 6. Or 2.5. Right?
Yeah, 2.5.
How many more cans does Tim open the first?
Okay. What are we given? Henry? Henry, tell us what we're given.
Well, what you're given is that each of the 1/3 room with 2.5 cans of paint.
So we're given 1/3. This is painted. And she does it with 2.5 cans. Okay? Okay? And then what do we need to find out, Henry?
We're trying to solve for how much will it be to finish painting the room, so what, everything else. So, first say you should times 2.5 times 1/3.
2.5 times 1/3.
Or 2.5 times 3. Yeah, so that equals 1/3, and trying to find the whole.
Yeah, you could do that. Okay, I see what you're saying. So he's going to multiply. Before you do this, Henry, I'm going to put some stuff on the board so everyone can follow this.
Yeah.
You've got part of the room that is painted, but then you have another part that is unpainted. I'm just going to write UNT because it's shorter. That adds up to the entire room, right? So the total, right? The total of the room. You have part of it painted, you have part of it that's unpainted, right? So if 1/3 of the room is painted, how much of the room is not painted? Anissa? Right, it's 2/3. So 2/3, and it has to add up to the total, which is going to be 3/3. That's the whole thing, right? Okay. Now I'm going to go back to what Henry was saying here, because this now makes sense why he said he wanted to multiply by 3. Because if you wanted to paint the whole thing here, and you know that 1/3 is painted by 2.5, then he multiplied it by 3. So what did you get for that, Henry?
So for that I got 7.5, and I guess if you subtract by 1/3, you get 5. Although I guess that now I realize it's an easier way to just use times that by 2.
You could.
Instead of 5.
So either way works. They would both come to this answer, because the question is, she needs 5 more cans to finish the whole room. Because right now, this is unpainted, but in order to finish the whole thing, she needs 5 more cans. Okay? Does everyone see how that works? Is that a little bit clearer as to how we found that? So the bottom line is, it says in the problem right here that it says how many 1/3 is painted. We know that 2/3 is basically double 1/3. So you could have just multiplied 2.5 times 2 and you would have gotten 5. You guys see that? So the answer is 5 here. Okay, let's continue to the next question, number 14. Keanu, you want to read that for us? The one that says back solving. It's about women and a track team. Okay. So that's a lot of information. That's basically like 3 lines worth. Like more than, is that 3 sentences? Yeah, it's a lot of information right there. So let's break it down piece by piece, okay? The first sentence, how do we break that down? There are twice as many men as women on the track team. That alone gives you some information. Henry, what would you say?
Well, I guess for the first one, 40, well, I guess the 2 times equals W, I guess.
It's the other way around.
Or 2.
Yeah, no, that works. You can say that. 2M. 2M. It's actually going to work. Yeah, you could do that. Okay, 2M equals W. Let's do that. Right. So basically, if we know men plus women equals how many people on this team? How many people are on the team? Anissa? 45. And we know that the men are double the women. So how many men are on the team? How many women are on the team? Who wants to guess that? Do you have it, Henry?
Well, I guess if they're 15 women on the staff, then they're 30 men.
Right.
That would equal 45.
30. plus 15 equals 45. That's true. Okay. Does everyone agree as to how we found out the actual number? Since it's double and we know it has to add up to 45. Okay. From there, can we solve this problem? Henry?
Well, from there it says, so, it says the first below, now let's see so 15 divided by 3 equals 5. And since the first, or 15 times 1/3 equals 5.
So that solves the problem. 5 women got the medal. That's correct. So since we know there's 15 women on the team and 1/3 of the women actually won, the answer would be 5. Does everyone see how that works? 1/3 times 15 equals 5. That's correct. What's tough about this is trying to figure out an answer, but if we know that there are 15 women on this track team, then we know that some of these answers are just not going to work. 10, 11, and 12 are just too big to be 1/3 of 15, right? 10 is 2/3, 15 is all of the women. That's 100%, right? That's not 1/3, that's not 2/3, that's 3/3, okay? So our best answer is 5 on that. Okay, let's continue. When it comes to doing this, we're doing something called back solving, where you're going from the answer choices and going through a process of elimination and knocking out answer choices. And when you're able to knock out answer choices, it makes it a lot easier. Let's do number 15 here. Who read this one? Henry, you read that last one, right? So Ineza, you want to read this one? Number 15.
A class of 30 is divided into 2 grids such that the size of the smaller grid is 2/3 of the size of the larger grid. How many students are in the smaller grid?
Okay, we need to do a little bit of translating here. How many groups are in this class? And what are they called? Henry?
Well, it's 2G equals C.
No, I meant one is the larger, one is the smaller. Let's keep it easy here. So there's larger plus smaller, and that's the class. Okay, that's what I'm looking for. Larger plus smaller equals 30. So instead of just calling this C, let's call it 30 here. Okay, we know there's a larger group and a smaller. Before we even do any math here, if the logic is telling us one group is larger, one group is smaller, then we know for a fact they can't be 15 plus 15, right? Because that would be equal sized groups, right? Since they're not equal sized groups, we have to designate numbers for what the smaller one is and what the larger one is. So we could actually do some back solving by looking at the answer choices. What numbers can we knock out already from what I just told you? For the smaller group, what can we knock out already? Henry?
Or you could knock out 20 because that would be too big.
What else?
Maybe you could knock out 10 because that's 1/2 of 3 and that would be.
No, we're just talking about the smaller group. And we're looking at, we said 15 and 15 doesn't work, right? We can't do that, right? So what else can we knock out for the smaller? It can't be 20, that's too big. That's more than 15. What else can you knock out? Megan? 16 and 18, too big, right? They're gone just like that because we're not looking at equal sized groups, right? So those are gone. So now you're just looking at 10 and 12. So let's actually figure those out for a second. So Henry, what are you going to do?
They're trying to find out what the 2/3 is, I guess. Or so they're saying 10 equals to 2/3 L, I guess.
Let's look at it this way. If this was 10, then the large group is 20. The question is now asked, the question told us that the smaller group is 2/3 of the larger. Is 10 equal to 2/3 of 20? Yes or no? Henry?
Well, I think it's no because it's equal to 1/2 of it.
Right, it's equal to 1/2. So this doesn't work. It's not 2/3. It's actually 1/2. So let's look at 12. Is 12 equal to 2/3 of 18? Why is it 18? Because if this is 12, this is 18, it's got to equal 30. You guys see that? So is 12 2/3 of 18? Do you guys see this? Tiana, do you see it? Sort of. Henry? What are we gonna? This is. Because if you multiply 2 times 18, you get 36. Divide that by 3, it equals 12. You guys see that? So the answer is that the small group is 12, and that would be the answer, because that's what this question is asking. What is the size of the smaller group? With a little bit of reasoning from the start, we knew that it couldn't be 15 and 15. And because of that, we knew that the small group could not be 16, 18, and 20. Those were just gone, just like that. And when we tested it out, we found out that 10 is not 2/3 of 20. 10 is 1/2 of 20. So that was out, just like that. So the answer is 12. Does everybody get how we got the answer? Or are you guys like, whoa, you get it? Okay, good. All right, good job. Let's go to number 16 here. And for number 16, let's have, who read this last one? This was, okay, Megan, number 16.
The teacher charges $12 an hour while his son charges $6 an hour. If the father and the son work the same amount of time together on a job, how many hours would each of them work for 9 plus the labor with $108?
Okay. So how would we set this up? Let's work piece by piece here. What do we know for sure? $12. Okay, $6. And what else do we know? What are we given? What kind of info are we? $108 total. So it's 108. Okay. So we need to know their hours, right? So we're adding this up. Do they work the same hours or different hours? Henry?
Well, if they're combined charge for their labor, how many hours do each of them work?
Yeah, it's the same number of hours for both. They're working simultaneously. Okay. Yeah.
And based on this, I guess you would say that 18 and 12 probably are
You mean 18?
18 would be out of the question.
No, you could do it because they're working together. I'm going to step in here for a second here. Because if you wanted to figure out the total money that the father made versus the son, okay, the father would be 12 times however many hours he works. For the son, it would be 6 times however many hours he works. If you could do this, you'll figure out how they add up to 18, right? I mean, not 18, but to 108, okay? Henry?
Well, yeah, so we have 18. We have to go to 12 times 18 would be already more than 108.
Right, so you have $18 times the number of hours. It's going to equal 108, okay? 108. What is the answer?
Well, like 12 like you go to cross out.
Yeah.
And then so it's like 9 times 8.
If you've reached this stage already, just divide it. 108 divided by 18 is how much? How much is it?
Well, it's 6.
It's 6. So they both work 6 hours, and together they generated 108. At this point, you don't need to back solve it because you've gone this far in the translation. Does everyone see why that translation works?
Yes.
It works? Okay. So that's how we get that one. Okay. Let's go with number 17. Kiana, you want to read that one for us?
Alan bought a motorcycle service cost of $0. This is if he received $875 not for the motorcycle, what did he pay for those money?
The key word to this question is profit. Why do I say that? Profit. What is the equation for profit? Do you know it, Henry?
No, I didn't know the exact equation.
There is an equation for profit. If anyone has sold lemonade, Girl Scout cookies, or a used pen that you didn't want but you wanted money for it, no? Henry?
Well, I guess it's what's left over from the expense.
Right.
What's your income minus your expense.
So here you go. Whatever you sold it for by your expense, which is what you bought it for. So we're talking about a motorcycle that Alan bought and sold, right? What are we looking for here? We're looking for how much he bought it for, right? So this is what we're looking for. How much did he sell it for? He didn't sell it for $88. If he did that, the profit is 88. So you got to put this correctly. This is 88. What did he sell it for? $875, right? So if we do a little bit of math here, what's going to happen, Henry?
Well, you're trying to find out what psi is or yeah, that's my C. So you can subtract 80 on both sides to the side. So and that equals $787.
You're subtracting 88, okay.
So that's $787.
787 minus B, and then what do you do?
So they're trying to get C, I guess. So sell like right
You just move the B over to the other side by adding B.
So you add it, and then that equals B equals $787.
So B equals 787. That's correct. So he bought it for $787. That's the only way that his profit would have been $88 because he sold it for more than what he bought it for. Okay? So you guys did a great job today. We don't have enough time to do the practice quiz, but you guys can do that for homework. I'm so generous, right? So the previous practice quiz, I think it's on page 40 and 41. And then this one starts on page 49. And your homework goes all the way to, I think it's 53 or 54.
52.
It's to 54, right? So wonderful homework for you guys. I know. Yes, I like to be generous, of course. So, but let's do that. Apply the things that you learned today. I think you guys did a great job. The previous one's on 40 to 41. 40 to 41. You see it? 40 to 41. Yep. Post-its, yeah. Or highlight. Okay, but those would be your homework questions from 40 to 41, 49 to 54. Next time I see you, because you're going to be gone, right? So, yeah. All right. Good job, everyone. Good. Any questions or any thoughts?
Is there going to be a class next week?
Yeah, we're going to have regular classes and stuff like that. I think for you guys, there's no more interference from the schedule of the ABC program. So.
I think that's the next one.
Yeah, you'll do it with another section. So.
But it's still kind of used.
Yeah. All right. Good job, everyone. All right. All right, Henry. Yeah. Yeah. What?
So you sold it for $88.
No, he sold it for $875.
Wait, is it June Thursday?
Yes. What?
Wonderful.
Homework.
Good for you.
It's not that hard. You can do it. It's only, a couple days. All right. Good job. All right.